Okay, so welcome to the final video on the trees and tree transversals series. And what I want to do in this one is I want to do a quick recap of what we've achieved in this section. So first of all, we started creating a single node. So each node is going to have two children, a left and a right. And for each one of the children, we define setters and getters. We also define an element. In this case, the element is of type person because this node is going to hold people. And I've given you from the beginning a class called person. The other thing is that these now could potentially hold any type of data depending on what you declare in there. But another option that you could do in here is that you can have a node genetic that could hold any type of data. Now, after that, we created that Linktree class, and that class had two main attributes: the root of the node and the size. We defined two constructors. We add a method to add nodes to the tree, and we implemented three transversing algorithms, the pre-order, the in-order, and the post-order. Now we define a visit method that only contains a system.out.println, but that visit method could be anything. So it would be a comparison, for example, if I'm looking for an element, or it could be a change or variable change if that's what I want to do. So the next thing just to wrap up that I would like to do is to use this class to create the connections between the classes and to create the interaction between the classes. So in this, what we did at the beginning, which was to hard code these connections between the nodes. Something that we can do is this time we can interact we can use the code that we have written to do these connections. So for example, I can create a new linked list or linked tree, I should say. Linked tree, my tree equals new linked tree. And something that we define in here is that we decide, we added two constructor, one with node root and one without root. So I'm going to define here that my root is n1. I can start adding nodes to the tree. So I can say my tree dot add. So my attribute takes three parameters. It would be the new node, for example, in this case n2. And it would take the parent, in this case n1, and what side it belongs to. So I'm going to say, for example, left. So I can do that and add all the different elements to the tree. So let's say I want to add node 3 as a right child of n1, and then I can add, for example, n4 and n5. Remove this one here. So, and again, we can do whatever we want. For example, I'm going to add n4 as a child of n2. I'm going to leave it as left, and I'm going to add this as a child of n3. Also, I'm going to leave it as left. So after I have added all my nodes to the tree, I should be able to transverse over the tree, saying my tree that, and I can use any of the transversals that we define. In this case, I'm going to start my transversing through node 1, but I could define any other. So if I run that, I'm indeed transversing in order my full tree. Something that you can see in there is that my left elements are going first, Obi-Wan and Leia in this case. My root of the whole tree, which is Amilcar, remains in the middle because it's in, and then all the right hand side goes left, which is Yoda and Luke. So another couple of things that I'm not gonna do, but you could potentially do. So you could add, for example, a couple of methods in here. So you could overload the methods. So you can create a pre-order, an in-order, and a post-order that automatically starts at the root of the tree. Absolutely up to you. You could add a method to remove nodes from the tree. That's also absolutely up to you. Or you potentially could add methods that add new elements automatically at the leaves level of the tree without you defining a parent. Those things could be done. It really depends on your implementation, but the important part is that you understand the overall logic of how these tree structures work. Well, thank you very much for watching. I know it's 6 videos, but I hope it is being of any help. So I'll thank you very much again, and I'll see you in the next one.